So in this video we are going to introduce the notion of vectors. So a vector typically represents three numbers. Okay, so a vector represents three numbers, and the mathematician studies that how these three numbers change when a certain thing known as the coordinate system is changed. However, in physics we give physical meanings to all these vectors, and we try to visualize the various physical quantities by virtue of these vectors. So let me try to make you understand that what a vector is in terms of physics. Okay, it is going to be an imperative tool in analysis of several complicated phenomena that we are going to study throughout the course. So a vector is a physical quantity that has both magnitude and a direction. That has both a magnitude and a direction. Okay, now we have come across physical quantities that has a magnitude, I guess, even before this level. So we know, for instance, mass is a physical quantity that has only a magnitude. So if we want to describe the mass of a body, then we can describe only by virtue of a magnitude and a unit. So if we want to say that something weighs, for instance, 4 kilograms, then 4 is the magnitude and kilograms is the unit, and this description is complete in itself. We do not need to specify any direction of the mass. So mass is something that is quite complete by virtue of only this magnitude. We don't need to specify a direction for mass. For example, temperature. Okay, we can also do specify temperature only by virtue of magnitude. For example, 37 Kelvin. Okay, the room temperature is 25 degrees Celsius. You don't need to ask what is the direction of this temperature. 37 degree Kelvin, which direction, is meaningless. Okay, so temperature, mass, time, for instance. Okay, time, it is measured in seconds, and it is also a physical quantity that can only be specified using a magnitude. Time seems to run only in one direction, and therefore there is a vast range of debate on time and geometries involving time. We're not going to get into that right now, but time for our purposes at this level is going to be a scalar quantity. Okay, now that's the name that I just said. These three quantities and many others that require only a magnitude and do not require a direction to be specified in entirety, these are known as scalars. Okay, so scalars are those physical quantities which require only a magnitude to be specified completely. But then what are some examples of vectors? Because we are trying to study vectors over here. So some common example of vectors are going to be force. We know that the unit of force is Newton. If you do not know, then don't worry, just keep this in mind. We are going to explore this thing in great detail, that the unit of force is Newton. Just like the unit of mass is kilogram, the unit of force is Newton, after the great English physicist Sir Isaac Newton. Okay, so let us say 4 Newton, but this description is not complete in itself. Why? Let me try to show you. Let us assume that you have a floor over here, and on top of the floor you have a block. Okay, now I tell you the block is resting on the floor. Now I tell you that apply a force of 4 Newton. Now if you apply the force of 4 Newton from this direction, the block is going to move towards the right. If you apply a force of 4 Newton from this direction, the block is going to move towards the left. If you apply a force of 4 Newton from the top, then chances are high that the block will not move at all. If you apply a force like this at an angle of, let us say, 37 degrees, then the block will have separate behavior than the previous cases that we just described. So if you are trying to specify something like a force, you need to mention in which direction you would like to apply a force. So you have to say plus direction. I'm going to set it like this. So 4 Newton may be a magnitude and a direction. So specify a magnitude and a direction. Same goes for velocity. Velocity, for now, you can simply define as a speed with a direction. Okay, now speed is a scalar quantity. Let me write it down over here. Speed in itself can be only specified by a magnitude, and therefore it is a scalar quantity, but a speed with a direction is known as a vector. So I'm going to give you an example. Let us say that you are moving 4 meters, 38 meters per second towards the right. Then your velocity is 38 meters per second towards the right. This whole thing must be said in order to describe velocity in entirety, like 38 meters per second towards the right. The towards the right part is also important, which is the direction of the velocity, right? So velocity is also an example of vector quantity. And another vector quantity that is much more fundamental than velocity, that should have been defined before velocity, is displacement. Rather, the rate of change of displacement is known as velocity. Don't worry if this does not make sense to you immediately. We are going to explore these two topics, velocity and displacement, in great details in kinematics, and we are going to explore the topic of force in great detail when we study dynamics and Newton's laws of motion, right? And mass, time, speed, they have been introduced to you before. Temperature is something that we are going to study in calorimetry. Okay, so displacement can be defined by some other things which are known as the position vectors. I know that now I'm going in loops. Okay, so position vector is the most fundamental thing over here, right? Position vector, and by virtue of position vector you define displacement, and by virtue of the rate of change of displacement you define velocity, and by the rate of change of velocity you define something known as acceleration, and by virtue of that acceleration you can find out the force that is acting on a body. Okay, so these is the hierarchy of the orders, and I think here I should mention acceleration. So position vector gives you displacement in some way that I'm going to tell you now. Displacement vector gives you velocity vector, and velocity vector gives you acceleration vector. Acceleration vector can help you to find out the force vector. Okay, now what is the position vector? The position vector is pretty much, let us say this is the origin and this is the point A. So the position vector is simply this vector drawn from the origin to A. Origin is the origin of any coordinate system. It can be a two-dimensional coordinate system or a three-dimensional coordinate system. I'm going to talk about coordinate systems in great detail in the very next video, but for now let us say that A has the coordinates x, y. This is elementary two-dimensional coordinate geometry that I am sure you have studied in 9th and 10th standards. So O is the origin 0, 0, and A is a point x, y. Therefore the position vector of A, let me call it as RA, is this particular vector that points from O to A. Okay, and let us say that there is a point B, and the coordinates of B are x1, y1, and therefore the position vector of B is this particular vector that starts at the origin and ends at B. Okay, this is RB. And what is the displacement vector from A to B? This is the important thing. The displacement vector from A to B is this particular vector. This particular vector is known as the displacement vector from A to B. In the next video, I'm going to show you how we represent vectors on pen and paper, and then I'm also going to show you how to add vectors so that I can tell you then how the displacement vector is going to be RB vector minus RA vector. Don't worry if you don't understand how I wrote this thing. I'm going to explain that to you in great detail in the upcoming video or in the video next to the upcoming video. Okay, so just keep in mind that vector is a quantity that has both a magnitude and a direction. Okay, so that was the key takeaway from this video, and we tried to distinguish between the scalars and the vectors. Scalars can be simply added by the laws of algebra that you have studied till now. Vectors require special addition, these types of things. You have to know special laws for addition of vectors that we are going to cover in the subsequent chapters.